A small village has an initial size of 50 people at a time t equals 0 where t is in years. A. If the population increases by 5 people per year, find the formula for the population size P of t. Let's make a small table of values to begin, and we'll look for a pattern. At time equals 0, the population is 50 people, so we can enter 50 in the first row. At the end of 1 year, there will be 55 people because the population increases by 5 people per year. But instead of writing in the number 55, let's think about the process. We're starting off with 50 people, and then we're adding 5 people. After 2 years, we'll need to add another 5 people, so that will be 50 plus 5 plus 5, but the shortcut for writing that would be 5 times 2. Similarly, after 3 years, there would be 50 plus 5 people for each of the 3 years that has gone by, so 50 plus 5 times 3. Notice the pattern. We've got 50 plus 5 times 3, 50 plus 5 times 2. For 1 year, we could write that as 50 plus 5 times 1. And for t equals 0, we could even write that as 50 plus 5 times 0. So what is our formula for P of t? P of t is equal to our initial population of 50 plus 5, the rate at which the population is growing, times the number of years, which is t. So P of t is equal to 50 plus 5t. Part B. If the population increases by a factor of 1.05 per year, find a new formula Q of t for the population size. Well, let's use the same strategy. We'll make a table of values and look for a pattern. Under this scenario, the initial population is still 50, so we can fill in 50 in the first row. But this time, the population increases by a factor of 1.05 per year. So to find the population after 1 year, we'll need to take 50, and instead of adding, we'll need to multiply. 50 times 1.05. After 2 years, we'll need to multiply the amount after 1 year, or the population after 1 year, by another 1.05. So that will be 50 times 1.05 times 1.05, but the shortcut will be 1.05 raised to the second power. We can use an exponent for repeated multiplication. For 3 years, we'll take the initial population 50 and we'll need to multiply by 1.053 times. So we can write that as 50 times 1.05 raised to the third power. Now notice the pattern here. We've got the initial population 50 times the growth factor 1.05 raised to the third power. 50 times 1.05 raised to the second power. 50 times 1.05 raised to the first power. And for time equals 0, we could even write that as 50 times 1.05 raised to the 0 power, because 1.05 to the 0 power is 1, and 1 times 50 is 50. So Q of t is equal to the initial population 50 multiplied by 1.05, that's the growth factor, raised to the power of t, the number of years that have gone by. Part C asks us to plot both functions on the same graph over a 30-year period. In order to do that, it would be helpful to have a table of values to show us how the population increased over the 30-year time period. So let's use our calculator to help us. Once your calculator is on, go to y equals. For y1, we'll enter p of x. We'll replace the t with x, and we'll enter 50 plus 5x. For y2, we'll enter q of x. We'll enter 50 multiplied by 1.05 raised to the x. And next we want to create a table of values. So we'll go to table set, which is second window. And I'm going to suggest that we start at time equals 0. And instead of incrementing by 1, we'll increment by 5. So we can see what happens to the population 5 years at a time. Make sure that the independent and dependent variable are both on auto. Then go to table, second graph. And now we can see under y1 that if the population grows by 5 people per year, the population will increase from 50 to 200 over the 30-year time period. And under y2, we can see that if the population increases by a factor of 1.05 per year, then it will increase from 50 to approximately 216. So let's use this table to sketch graphs of both functions. To graph y is equal to p of t, we'll plot the points 0, 50, 575, 10, 100, and so on until we get to 3,200. After plotting the points, we can see that they're collinear. There's this line that will fit the... After plotting the points, we can see that they're collinear, so we can just simply draw a straight line that passes through all of these points. To sketch a graph of y is equal to q of t, we can plot the points 0, 50, 5, 64, 10, 81, and so on until we get to approximately 3,216. For y equals q of t, we can see that the points are not collinear. We'll just connect them with a smooth curve. D. Use your graphing calculator to determine the coordinates of the points where the graphs intersect. Interpret the meaning of the intersection points. Well, looking at our graphs, we can see that they both intersect at 0, 50 because the initial population under both scenarios is 50 people. However, the other point of intersection is not quite as clear. We can see that the two populations will be approximately the same, somewhere between 25 and 30 years, and that population will be approximately 190, but let's use the calculator to get a better estimate. We'll go to Window to set up our viewing window. For our x values, we'll let them range from 0 to 30 with an increment of 5. For the y values, the initial population for both scenarios is 50, so we'll start at 50. And for y maximum, the population for q of t, the maximum population was about 216. So we'll enter something just a little bit bigger than that, like 220. And I'm going to suggest an increment of 10. Sketch the graphs. Notice that they look like the ones that we just drew. To find the point of intersection, we go to Calculate, Second, Trace. Select number 5 for intersect. Press Enter to select the first curve. Enter to select the second curve. And then use your right arrow key to move to the intersection point that you would like to find, and press Enter one more time. And the intersection is approximately 26.6, 183. So let's indicate the points of intersection on our graph. The first one is 0.50, and the second one is approximately 26.6, 183. What is the meaning of these intersection points? Well, it means that under both scenarios, the populations will be the same initially and after about 26.6 years. Initially, both populations will be about 50, and after 26.6 years, both populations will be approximately 183 people.